All right, you guys, this will be the last day that we do practice. I mean, you can rewatch old lectures and obviously practice on your own. The intent of class time isn't to be the only time some people come to practice. Okay? So there's only so many of these examples I can do over and over and over again. So we're going to spend the day clarifying everything. We'll go back and make sure you know what is Content 3, Unit 3 is on. And then starting Wednesday, I'm moving on to muscles. Don't freak out because we got to get to muscles. And muscles influence our motion. So actually, we'll still be practicing things like position and movements, which is going to add the context of the contractions of the muscles that are influencing our motion. Okay? But what we don't want is to keep practicing the same things over and over and over and over again till we have a week and a half, 2 weeks up to school, and then we have to pressure cook all the muscle content at the end. We're already tired. We're already exhausted. It's already towards the end of the semester. So we want to make sure that we kind of eat the apple in small bites. Okay? Before I get started with our first example, does anybody have any questions? Maybe you were studying this weekend and you had a question about cervical trunk, wrist, radial ulna, anything like that. I just wanted to give everybody a chance to speak or forever hold your pronation. No, we're good? Good. Means everybody's going to ace it. So let's look at this photo. What can we tell from a photo? Can we tell motion from a photo? To infer motion, we do not assume in this class. Hopefully, you'll not assume when you get out of this class. But to infer motion, we need more context. We need more information. Is he coming up? Is he going down? Is before, after, pre, post? More than likely, he's probably just holding this position for the photo. So there's probably no motion to begin with, even with context. But if we saw a blur, let's say he was halfway, and we just saw a blurry image of him moving, I have no idea if he's coming up or down. Okay. So we cannot infer. That's why on the test and in class, I always give you enough information so that you can solve for C. A plus B is equal to C. Got to have A, got to have B. Or you could have A and C, solve for B. You have to have enough information to be able to solve those algebraic equations, right? But what can we infer here? Position. Where is he at? We analyze motion joint by joint. Motion is just change in position. So indirectly, we can still analyze position joint by joint. Let's start distal and work our way to proximal. Let's start towards the end. His fingers are flexed. Remember how I said, guys, I don't, you know the reason I don't lecture about the fingers? Because you're either into a ball or you're out of a ball. Flexion, extension. Come on. Okay? So his fingers are more in the fetal. His fingers are flexed. What about his wrist? Ulna deviated. Outstanding. Is this a good image or view to really assess his sagittal? Like, in other words, if you're like, well, what about, is he flexed or extended? I'll be like, that's not a very good view to see that. If we had a side view, I could kind of see if his wrist was, right? But probably not enough to be obvious. I mean, obviously, if he was here, that's a different story. But if he was slightly deviated, a front view really wouldn't give me that picture. Sometimes we have limitations with two-dimensional images with three-dimensional movement possibilities. That's okay. But we can see that he's ulna deviated, right? That's a good view. Elbows. Flexed. On the test, and this is where it's really hard for me sometimes to, I got to keep my mouth shut. But it's, teach with repetitiveness. On the test, I'm going to say, what's the position of his elbows? And I'm going to have pronated or supinated as options. So if you put that his elbows are pronated or supinated, you don't understand how the elbow works. Does that make sense? Like, You have to not make those mistakes. What can the elbow do? Flex and extend, flexion, extension. We wouldn't say that the elbow has, plantar flexion. We wouldn't say that it has supination. Okay? So the elbows are bilaterally flexed. How about those radial ulnar joints? What do you think? Are they more pronated? Don't answer it out loud. I want everybody, this is a tougher one, even though we've gone over it in class several times. Think about it. Is he more pronated, more supinated, or is he mostly halfway? Don't answer it right away. Give it some thought. And while you're giving the radial ulnar joint some thought, does it make sense that he's ulna deviated so that he could keep his fingers under the bar? Like if his wrist stayed straight and anatomical, he wouldn't be able to grip under the bar. Right? So it makes sense that you have these movements to kind of compensate and change and glide and grind so that you can maintain the grip of the bar while your arms are bringing it up. Okay? Radial ulnar joint. Pronated, supinated, or semi-pronated? Mostly. Where is he mostly? Is his thumb more medial, lateral, or halfway? If you follow his thumb, you see how his thumb, that's why I chose this picture. You see how his thumb's on top of the bar? If you took like a little Lego man and walked down his thumb and followed his forearm, would you be on the outside of his arm or the inside of his arm? Hello, darkness, my old friend. I've come to talk to you again. It's an old boomer song called "The Sound of Silence." Picked a bad week to stop sniffing glue. Is the thumb medial or lateral? Or maybe it's this. Maybe you guys are uncomfortable with me asking you questions. Maybe I just need to move on to muscles. Okay? Is the medial part of his arm on the top or the bottom of this picture? One of those is correct. All right, everybody, let's try this while I try to reset my mind, because this is frustrating. Put your elbows at your side if you choose to, and notice where the outside of your elbow is. Now do this. Does that confirm or change your answer to where the lateral part of your arm is in that picture? Is it on the top or is it on the bottom? Ta-da! Huh? Does everybody see why the lateral part of your arm is at the top of this picture? Why do you guys, and I'm genuinely asking because I want to learn, why is this so tough sometimes to see? And maybe the answer is, dude, it's Monday. It's 7:30 in the morning on Monday. Everything is tough to see. I respect that. But it's not like this is the first time we talked about this stuff. So maybe if I can understand why it's difficult to see, I can find ways to make it easier to see. But I can't do that without feedback. I can't do that without interaction. Because it's just me talking to me. And you know why that doesn't work? Because I've been seeing this for 30 years. I need to learn how to get some of you guys to see it. And if you and I would assume you see it, because I assume everybody can see it. but our answers don't match up with what I'm perceiving. Thank you so much for saving me here.
I think for me personally, like I've been practicing the movements that's in the textbook, or whenever it comes to like applying it to actual like actual exercises or actual positions like that. That's not as simple as like, oh, just this or this. You get what I'm saying? Like the standard ones, that's when writing kind of tricky with it.
Okay.
Because I'm trying to like think about relating this to what I've seen so much with the textbook and everything.
Now, are you answering, first of all, thank you for breaking the silence, but are you answering the question about overall motion, or the fact that the top part of his arm is the lateral part of his arm? Because that's what, like I was trying to break it down, and like even that part I think is, like if I said the nose is the front of my head, and I look to my right, my nose doesn't change, even though I might be like on the right side, like that's still my nose, right? So it's almost kind of like I'm asking that question. Like if the outside of the elbow had a nose, and you did this, that's still your nose. So like if your anatomical position and this is the lateral part of your arm, bringing it up doesn't change the fact that it's the lateral part of your arm. So now if you follow the thumb, is the thumb on the lateral or outside part of your arm, or is it on the medial inside of your arm? Lateral side of your arm. Does that make sense? So if it's lateral, where is your radial joint at? Supinated. I can't help but think that this is all part of global and local, like where, this is lateral, but if I bring it up, now that's no longer outside, it's up or something. I don't know. But it's still the outside of your arm. No matter if you bring it in the front, that's still the outside of your arm. No matter if you bring it on top of your head, this is still the outside of my arm. Even though it might be in the back of my body, it's still the lateral part of my arm. If he lowers the bar down, what position would his radial ulnar joint be at the bottom? Don't answer it right away. Try to give it some thought. If he lowers the bar down, and if you're having a tough time seeing it seated, stand up and do it if you want. And especially if, this is where I think the changes need to be made. If you're making the grade that you want to make, you do whatever you want. But if you're not, let's find ways to get there. Let's find different ways to approach this. You could use your pin. You don't have to have a full bar. You can have like one finger on one end of the pin and the other, if he's on the other end of the pin. You can do it. But I can't make you. I can't make you study. I can't make you practice. I can't make you come at 7 in the morning with questions. I can't make you ask questions before class. I can't make you do it, guys. You know what I can do? Ask questions that I've repeatedly given in class and grade you on. That's what I can do. That's all I can do. I'm not going to come and save you and rescue you at the end of the semester when you care about your grade. I can save you right now. I can help you right now. Right now is when I can help you. But I can't help what I don't know. Okay? So you lower it back down. What is the new position of the radial ulnar joint? Maybe it's the same. Maybe it's different. If you can't see the motion, which is fair, try to just get the position change. And the position change will show you how you had to move. If you see the change in position, then you solve for the motion change. Okay? At the bottom, did you stay supine or did you pronate? Because there's only one of those two things that's happening, because if you're already supine, you can't supine anymore, okay? So you either stayed in that same position or you had pronation. What do you think happened? Pronation, good. Bilateral radial joint pronation. Now, I understand, guys, I do. I understand that you want to write that down. But more important than that, do you see it? Because if you see it, there's going to come a day when you don't have to write it down. You just see it and you know it because you understand it. Okay? Yes, ma'am.
Would you mind, like, explaining what is pronation? Because like, whenever I think I'm just turning around, like, I'm turning something or going down to
It's
it.
impossible to not. And I'll show you why. If we stay supinated, remember we have to keep our fingers under the bar, right? If we stay lateral, this would have to happen. I'd have to snap the bar in two, okay? So what's gonna happen is, as I come down, in order to keep my fingers under the bar, I'm gonna pronate. So the radial on the joint motion is happening with the shoulders, because the shoulders, as they come down, are trying to take me here, and the radial on the joint is gonna cancel that so that I can keep my grip.
Does it do a beat like at any point during this like singing pronation?
Yeah, when you're halfway.
Slow down.
Well, semi-pronation is not a movement. Semi-pronated is a position. It's like halfway to full pronation. So you don't have a motion called semi-pronation. You either have pronation or supination. I'm trying to think of an analogy. So think of Louisiana separated into three parts. You have south, you have north, and you have central. So it's like if you're traveling up to Shreveport and you stop in Alexandria for gas, and you could say, you know, I'm halfway there, right? So a semi-pronated position is where your thumb is halfway between lateral and medial. So you're going to pass through is what I'm trying to say. So as you go down, you're going to pass through Alexandria. You just won't stop unless you literally just stop. So you would just be passing through. The reason it's kind of in our lexicon is because it's so functional. You know, this position of grip is very practical. You know, we do a lot of things with this position of grip. So that's why it has a special position name. But this isn't anatomical. This is anatomical. Did that answer that question? Good. Yes, ma'am.
Okay, so if it's the lateral radial pronation, in that position, will it be the lateral radial supination?
Okay. The problem with what you just said was that you said position and emotion. That's okay. That's how we learn. That's why I'm dying to get to do that so that we can learn from it, right? So to start off, he is supinated, but he doesn't have supination until he actually has change of position. So from here, this position, we say, all right, where is he at for our Louisiana analogy? Okay, let's say supination is going north and pronation is going south. So I'm saying in this position, he's in Lafayette, because that's home. But when he comes down, he's in Shreveport. How do you go from Lafayette to Shreveport? You have to travel north, right? How do you go from being supine to being prone? You have to have pronation. Does that make sense?
Yeah.
Good. Yes, sir.
What are some more versions of the radial?
There's only so many I can do. I will, but like It's gonna be the same ones we've done in here, but ones with absolutely. But do you see my point? There is a game that is being played in education. And I can say this because I'm tenured. And that is, give me what is going to be asked on the test so that I can memorize it, that I can get it right, so that I can get a grade, so that I can accomplish the things I need to accomplish with that letter grade. Guys, I get it, man. I played the same game. But what I'm trying to do is give you your money's worth for your tuition, which is ridiculously exponentially going up and up and up and up. None of that's coming back to me. But what I'm trying to do is arm you with tools, because I can't give every scenario. Even though I want to, there's going to be infinitely many scenarios with many different body types, new exercises, new ways to do things, people that are hyper flexible, which I'm not. And you're going to have to use that tool belt that I'm teaching you how to create to figure these things out. That's what we're working towards here. So I get it, man. I understand that your comfort zone, not fault of yours, your comfort zone is, tell me 2 + 2 is 4 so that I can expect what's 2 + 2. Metaphor. But on the test, I'm going to teach you math, but on the test, I'm never going to give you 2 + 2. It might be 2 + 3. It's still going to be math, but it'll be a little different, just to see if you can take out that toolkit and fix the problem, okay? So that's why I'm spending so much time not just saying, okay, guys, when he goes down, it's this. I mean, I'm trying to take time to say, look at the position. Look at where it is at. Look at where it is now and see how it had to move to get there. Okay? Yes, ma'am.
To determine the position of the radio repository, should you always use the thumb as the landmark?
Thumb rule. Thumb and the elbow in terms of medial and lateral works every time. It works every time. It's not even like on Anchorman, like 60% of the time it works every time. It works every time, and the reason is because the wrist doesn't spin. If the wrist spun in its transverse plane, then this rule would be null and void. But the fact that it doesn't means that only the radio ulna joint could reposition the foot. Remember how the thumb was the foot? That's it. Now, most of the time, this is, again, where y'all were introduced to this. Y'all were introduced to this. And I'm not saying the teachers that introduced you to this was wrong. Not at all. It's just we're kicking off the training wheels and we're going on a bike ride. All right? There's no more, we're out of diapers now. We're growing. We're growing and we're evolving and we're getting bigger. And so we got to be able to see that this is the same as this. Or as the same as this, like we've done in class before. So it's more to the story. Cinderella, the story, can be a 10-page children's book, or it could be a 3-hour epic movie. And believe me, this isn't a 3-hour epic movie, but there's just more to the story than just... Boy, I'll tell you, if every motion could just be the Dorton Soup Bowl, boy, things would be super easy. Yes, sir.
So this is also bilateral scapula rotation?
Yes, I was hoping to get there. Absolutely. Absolutely. And what would happen to the shoulders? Okay. And what about in the frontal plane? Chicken dance. Ab. So how do we clarify with planes? So in other words, frontal plane, that's going to be the ab and the ads of the shoulder. Sagittal plane is going to be my flexion extension. And then the transverse plane of the humerus is going to be the internal and external rotation. And then the scapula, to your point, which is an excellent observation, the scapula is going to assist. Guys, that's why if you've ever done upright rows, like, yeah, you might feel them in your shoulders, but you know where you feel it a lot? In your traps. In your traps. Because those traps are elevating the scapula and upwardly rotating the scapula. And in biomechanics, we're going to learn about the specific muscles of those groups and how they're pulling and how they're helping to move those joints. So there's a lot of stuff happening here. Here's the lesson. There's a lot of stuff happening here. How do we process all of that stuff that's happening? And that's we try to break it down. We don't try to process everything at once. We say, okay, there's a lot of stuff happening here. Let's start in one place and work our way up or work our way down. In this case, we started at the wrists. Well, technically, we started at the fingers. And then we did fingers, wrist, elbow, radial ulna, shoulder, scapula. So the scapula in this photo would be upwardly rotated. The shoulders would be abducted. The shoulders would be externally rotated. But when he goes down, that's where we have to put our concepts of change in position. So would the wrist stay in this position as he goes down, or would they move? If they stayed in this position, he'd have to snap the bar. Think about it. So what motion do you think we're going to have at the wrist on our way down? Good. Good. You see how this works? And whether or not you see it or not, that's just keep grinding, keep trying. Authentically keep grinding and trying. We've been playing this verbiage game of before and after since probably the second week of class. Keep grinding. Yes, ma'am.
So when you get all the way to the bottom, then this wrist being on top?
Mm-hmm. More. Yeah. I think it depends on his grip, right? But I know this: he's not going to stay ulna deviated. As he comes down, he's going to be here, which is not there, because he'd have to snap the bar. Does that make sense? What are the elbows going to do when he goes down? Good. Bilateral elbow extension on the way down. And again, unless he snaps the bar, he'd have to snap the bar like this if he wanted to stay supinated. So in other words, as he comes down, you have to snap the bar, and it's like a pretzel. So he's going to have bilateral radial ulnar joint pronation as he goes down. Remember, Superman flies prone. Shoulders on the way down. On the way down. AD or AD? AD, good. And scapula on the way down. Outstanding. Outstanding. Yes, sir.
Do you have downward rotation from
The scapula is upward. I say that not normally. You can have. This is the unfortunately, this is how my brain works. I would say through normal range of motion, you can't. However, you have these kind of examples. So there are certain peoples that's their traditions to have like the neck rings. And what that does is it atrophies their scapular muscles. So what you see as a long neck is actually a normal neck. It's just they're so depressed from the scapula being atrophied, the muscles of the scapula. So the scapula can actually depress and downwardly rotate past what normal is because they suppress those muscles. When they take those rings off, they have to be careful because it's like kind of a newborn baby not having the musculature to move their head around. So 0.0001% of the population but technically you can go past normal if you just like totally shrink the muscles to do so. So I think a better way of putting it now that we have those rare examples out of context is that in anatomical position, your scapula is down. Okay? All right, let's reverse uno card. He pulls the bar up. So let's do okay, she pulls the bar up. Bar, dumbbells. That's a good one. That's a good one, too. That's a really good one. That's an interesting one. That's a really good one. You could really follow the thumb to the lateral part. It's a good one too. Follow the thumb to the lateral part. Really good one. Follow the thumb to the lateral part. Let's use this one. So up and down. So she pulls up. Let's instead of distal, let's start proximal. So scapula on the way up, upward rotation and some elevation. Get it up and lean. Shoulders. Abduction. A little external rotation. For the test, it's most likely going to be the abduction in terms of asking you about the shoulders. And again, if you're like, well, how do you know it externally rotated? Well, when she started here, her biceps are looking at each other. True? In this before. And then when she comes up here, they're looking at you. They went from here to there. Does that make sense? So we did scapula, we did shoulders, elbows on the way up, flexion. And the radial ulna joint on the way up is going to have supination. And again, the reason is so that you can keep your hands under the bar. If she stayed, does everybody agree that she's mostly pronated down here? Cool. If she stayed prone, she'd have to hold the thing with her thumb. Does that make sense? If she stayed prone, remember Superman flies prone. If she stayed prone, she'd have to have the little band with her thumb. The only way to keep her fingers under there is to have the supination. Okay. Elbows, flexion as she pulls it up, extension as she pulls it down. Back to the wrist, ulnar deviation as she pulls up, and radial deviation as she goes down. Any questions about these types of exercises? How about you guys offer me an exercise and we'll analyze it together? Pull-ups, cable stuff, rows. What do you guys want me to pull up here? Maybe there's one y'all were doing this weekend that you're really curious about. Any upper extremity exercises? Let me put it up to you guys. Dips. Dips. Now dip, baby, dip. Yeah. Dip. That was such a boomer joke. All right, there's some dips. It's my kind of dip. All right. Okay, guys, just a reminder, you're going to have a lot of combination and that's okay. There's a reason you have cardinal planes, north, south, east, west, but then you have like northeast, northwest, southeast, southwest. So a lot of our shoulder motion isn't just going to happen in robot world. It's going to happen in some combination, but that's why we clarify planes. So in other words, if I was doing, if I was doing a raise, but I didn't go straight forward, I didn't go straight out to the side, I came at an angle, that's not some new motion, that's not some new plane. It's just the part that was sagittal is flexion, and the part that is frontal is abduction. It's a combination of flexion and abduction. Does that make sense? Just like if you were traveling north and east, it'd be a combination of north and east. We call it northeast. So don't get caught up in, well, how do you know it's this and that? Probably it's a combination, because most of our motion is combination. But how I'm going to clarify it on the test to make sure you answer what I'm asking you is planes. So if I say, okay, guys, let's analyze his sagittal movement of the shoulder, well, then all that frontal stuff doesn't matter. That have and the have doesn't matter. We're just talking flexion extension. We can have a frontal conversation. I would say, give me a better view so that we can have that frontal conversation better. But based off of this view, I'm going sagittal. Does that make sense? Okay. So let's have a sagittal conversation. What things we can talk about? We could talk about scapula. We can talk about shoulder. We can talk about elbow. Let's see if we can talk about, probably not talk about radial ulna for this one. And look at that look of concentration. Cool? You guys give it some thought. Yeah, I guess we could have a radial ulna. I don't like the view of this, but I guess we could have enough clues to infer. Nah, I don't like it. Remember, guys, for me to give you a fair question, there has to be a view easy enough to see these changes. An extreme example of that is, I'm not going to give you a picture of someone's upper extremity only and ask you what happened at their ankles. Like, you have to be able to see these changes to be able to infer motion. So I don't like this, because if we had a view of the front, I think we'd be able to kind of see how that thumb is in relation to his elbow. But this side view, I don't like it. I'm not good. All right, this one is tricky only because of global ups and downs. So when he brings himself up for the dip, when he goes up, so that would be from right to left. When he goes up, that's actually because his scapula went down. That makes sense? So his scapular depression actually brought his body up. Make sense? In other words, if I ask you which picture is most like a shrug, like when you bring your shoulders up, even though that's your scapula, you'd say, well, the one on the right, well, that's elevation, to go from here to there. And from here to there is depression. Make sense? Okay. I don't think there's going to be as much upward and downward, because I think the motion is mostly sagittal here. But there can be, and I'm not going to ask you this on the test, but that scapula on the right side is tilted, which is kind of a combination of elevation and protraction. That's just FYI. I'm not going to ask you that on the test. It's going to be the obvious ones. So for this question, I'd ask you elevation or depression of the scapula. 100% can ask you that. Let's go shoulder sagittal, flexions and extensions. From left to right, flexion or extension? Extension, right to left. Good. Flexion to anatomical. And if you say, well, Campbell, I thought flexion got you into fetal. It does. You're more in fetal here than you were out here. Make sense? He's as far away from fetal as possible. He got closer to fetal when he got back to anatomical or to it. Okay? So extension on the way down, flexion on the way up. Elbows, extension on the way up, flexion on the way down. Cool. And there's nothing else there that we have a good view of to be able to definitively say he is or he isn't. And this should make sense, because remember, when we were doing the radial ulnar joint with the shoulder, mostly frontal, because in the frontal, that's when your shoulder has to spin. So if we're mostly sagittal, there's no need to do that compensation. Does that make sense?
Can you explain why the scapula is in elevation and not retraction?
No problem. No problem. And the answer is that this exercise is about ups and downs. True? So let me give you one that's going to have like so like this exercise is going to have a lot more of the protraction, retraction for the ups and the downs, because technically from his body's perspective, it's about fronts and backs. You're welcome. Does that make sense? Optimize your PC. Yeah, I know I can't spell. All right, let's talk about this. Let's analyze shoulder. Ooh, this is actually really cool because we can analyze radial ulnar joint from here. Wow. Okay, so let's make some assumptions. Sorry, I mispronounced inferment. This is a good one. Yoink. All right. So here's what we know. Shoulder, sagittal. However, when she's here, I bet you in RC Cola at the next Delcom Strength Festival that her bicep is facing forward. And on the picture on the right, her bicep is facing you guys. Does that make sense? So that tells me some stuff. That tells me some stuff in terms of how her shoulder had to move and how her radial ulnar joint had to move. Okay. So I'm going to give you some joints to analyze. We can do wrist from left to right. We can do elbow from left to right. We can do radial ulnar joint from left to right. We can do shoulder from left to right. And we can do scapula from left to right. We can do right to left too, but for this one, we'll go left to right. It's overwhelming. Man, that's a lot. That's why you take it joint by joint. And you don't have to do it in a certain order. Do it in your order. Do an easy one. If elbow is your thing, do the elbow first. Get some confidence. See the elbow. Check that box. Then progress to another. Check that box and progress to another. And check that box and progress to another. If one of my colleagues or a student comes and says, hey, I'm doing this paper and I need some help for these motions in this complex thing, I'm not just going to rattle off stuff. I'm going to do I'm not a hypocrite. I'm going to do exactly what I'm teaching you guys. I'm going to look at the progression and I'm going to say, okay, let's start with the ankles. Joint by joint by joint by joint by joint. Okay? Guys, this is the part of the semester that's the toughest. I know I don't need to tell you anything you don't already know. And you got papers due, you got projects due, the lights at the end of the tunnel. We have Halloween, and then you blink your eye, you got Thanksgiving, you got all these breaks, you got all these things, and Christmas is right around the corner. So as somebody who cares about your education, sometimes I need to wear that black hat and remind you guys, come on, let's keep growing, let's keep pushing. Let's not give up. Let's keep fixing. Let's keep mending. Let's grow our toolkit so that we can solve these problems. And I'm hoping that a lot of you, I mean, you're in kinesiology, you're active, or you watch. You have a hobby of watching sports or activity or exercise, and so that's a great way to practice. And if there's something you're not sure about, bring it to me. Bring it to me before class. Bring it to me after class. Bring it to me during my office hours. Let's figure it out. I might use it in class. I might use it on a test. Done that before. All right. Right wrist radio deviation from left to right. Any problems or questions about that? From left to right, radio deviation. From right to left, ulnar deviation. Cool? Right elbow extension from left to right, and then flexion when she comes back. Extension, flexion, extension, flexion. Now here's where the context clues tells me the radial ulnar joint. Because when she's here, she's semi. She could go in either direction, right? But when she's here and that bicep is facing here, but her thumb is facing there, that tells me she had to go from a semi position to a supine position. And therefore she had to have supination. If you got that right, pat yourself on the back. But there were clues in the picture. That's the only reason I could ask that, is because I saw her bicep there, and I know her bicep wasn't there. You know how I know it wasn't there? Because if her bicep was facing in the same way, her elbow would have to be here. Clues in the clothing. Shoulder, flexion, extension, flexion, extension, flexion, extension, flexion, extension, flexion, extension. Scapula, protraction and upward rotation, because anytime your hand comes up, for the purposes of this class, the scapula is going to lean to help accommodate that glenohumeral joint, okay? It doesn't have to just be frontal. We're good? Just a,
Shoulder also has our rotation.
yes, absolutely. Outstanding. I didn't say it, but I was definitely implying that her bicep was facing here and now it's there. Absolutely. Thank you for catching on that. Internal rotation. So that's why her radial ulnar joint had to move. Her radial ulnar joint had to move so that she's not here. Does that make sense? Good. Thank you. Someone was at the same point, or
She's not forced in it, right? Because
say that one more time.
So when she's here, she's not forced in it, she's still going more.
Yeah, I'm just using her bicep.
Right.
I'm using her bicep as a mark. So I guess for me, my bicep is facing here, and I'm all the way supinated. So it might just be how your range of motion works. Like your bicep, as I see it, is actually facing more up than across right now.
Why do this?
Yeah, you see how it's facing up?
Yeah.
So like hers isn't facing up, hers is facing you.
Okay.
Yeah. Good. No, that's good. It's good. Steve Kirk is good. All right, guys, we're dismissed. Say that again. Her scapula is going to have protraction, head over the wall, and it's going to have upper rotation, going to have reposition the socket as her hand goes up, as her arm goes up. Remember, even though you don't make see her hand, her shoulder is flexing. So if her elbow didn't extend, her hand would go up. Hey, thank you for talking today. Hope that helped. Thank you for your feedback today. Hope that helped.